Welcome back, class. Today we're going to look at Chapter 2, Technology Infrastructure, the Internet, and the World Wide Web. A little introduction. Most Internet users are using smartphones or tablets to connect to the Internet. And we all have smartphones with us all the time anymore. So high mobile device usage is taxing existing technologies and threatening to overload networks. And one of the reasons that happens is because there's so many more devices actually connecting to the internet. So the current solution is for wireless providers to add more cell phone towers. And this can be a little expensive, and locations can be hard to find. If you've ever driven in a rural area and tried to get cell service, you know how frustrating that can be. Mobile data traffic is expected to triple by 2018. Of course, this is 2019, and it's just expected to continue to grow. Computer network is any technology allowing people to connect computers to each other. So if you're on the internet, you're on the largest network in the world. Internet with a small I is a group of interconnected computer networks, and Internet with a capital I connects networks all over the world. So the biggest difference here is if you're in an organization, in a work organization, let's say, or at a school, you have interconnected computer networks. That can be considered a small I internet. Whereas when we log on to Facebook or something like that, we're on the capital I internet. And then we have the World Wide Web, which is a subset of internet computers that are connected to each other. And a lot of people use the term internet and the web interchangeably, but they are not. The web actually runs on top of the internet, and we'll discuss that more in a minute. Just a little history of the internet. In the early 1960s, the Defense Department had some nuclear attack concerns. There were large mainframes, which were powerful computers. We didn't have computers as we see now. And leased telephone company lines were used to establish a single connection between sender and receiver. So, for example, you have an organization in one location that wants to connect to another, you had to have a direct connection of a phone line. In 1969, Advanced Research Projects Agency, known as ARPA, was formed, and it was the first to use a packet network which connected 4 computers. And it was called ARPANET, which was the earliest network, which later evolved into the internet. But originally, it was a couple of universities. It was used for academic research. That caught on, and then in 1972, email started to become more widely used. Not like we see it now. It was mainly character-based. The military and education research users continued to grow, and then mailing lists started to appear. In 1979, Usenet was created, which was Users News Network, and it continues now with news groups. Network applications improved and tested by an increasing number of users from 1979 to 1989. In this period of growth, there were some security problems that were recognized. And then in the 1980s is where the personal computer use explosion happened. IBM came out with computers that were affordable for organizations to buy more of, and then eventually they became more affordable for home users. Some commercial use of the internet. The National Science Foundation, NSF, is what provided funding for the internet, and it prohibited commercial network traffic. So businesses had to turn to commercial email providers, and this is back in the 80s. The larger firms built networks. The MCI was one of the first organizations that ran lines underneath the ocean to connect countries. So 1989, NSF permitted two commercial email services, MCI Mail and CompuServe. These were commercial enterprises that could send email. In 1991, the NSF further eased commercial internet activity restrictions, and privatization of the internet was completed in 1995, which basically means that operations were turned over to privately owned companies, and no one owns the internet. Now, there are countries that can control what is seen in their country, such as China. They can control what's seen in the company, but they don't own any part of the internet, which makes it difficult for governments to police different areas. Network access providers sell internet access rights directly and through internet service providers or ISPs. So for you to get on the internet, you have to contract with an ISP. It could be Cincinnati Bell, or it could be Spectrum, or whatever organization that you're paying money to. Consistent and dramatic growth in the number of internet hosts have grown over to more than 1 billion today. There's something called the Internet of Things, and this is a connection of devices not used by persons that's rapidly increasing. This will be things like optical scanners, switches, some background, different things. But this has also kind of grown because we have so many more devices connecting to the internet, things that you don't think about. Your cars, appliances, smart TVs. So, and this falls under the umbrella of the Internet of Things. How this works, and I'm just going to briefly describe this. You have packet switch networks. You have a local area network, or a LAN, which is a network of computers that's located close together. So within the school, let's say for an example, there's a local area network. All the computers are connected to one another. In order to access other areas, they have to go out onto the internet, so they connect to a wide area network. And a wide area network is a network of computers connected over greater distances. And when you have a bunch of WANs connected together, that's where the internet comes from. A telephone call establishes a single connection path between caller and receiver, and then transmits data along that single path or circuit. This is going back to packet switch networks. Circuit switching is centrally controlled and is a single connection model. And it's not resistant to failure because a break in any circuit causes interruption and data loss. Packet switch networks breaks files and email messages into small pieces called packets. So it takes the data and breaks it down into little packets. And then those little packets are sent over the wire, or the leased line, or the whatever line that the telephone company is providing. And they're sent over in packets. They're broken down on one end. They go over in packets, and on the other end, they are reestablished and connected together as full packets. This is a picture that kind of shows how much is involved in the internet, but you have a few things here. You got the backbone router. These are the background of the internet, where countries are connected and things like that. And then you have different individual locations connected. You have to use protocols on the internet. Protocol is just a collection of rules. And in regards to networking, it'll have protocols. Computers that communicate with each other must use the same. And the one that I'm going to mention, TCP/IP, is one that is used on the internet. TCP/IP stands for Transmission Control Protocol, IP. And if you, IP, I'm going to focus on that for a minute. Every device that's connected to the internet has to have a unique IP address. Currently, we use IP version 4, and there's also IP version 6 out. 6 was developed because we started running out of IP4 addresses. Because IP4 addresses is a 32-bit number that identifies computers. And computers use the binary number system, which is base 2, so it uses either a 0 or a 1 instead of the system that we're used to, which is base 10. Routers break the messages again into packets that contain the source and destination IP address, and the dotted decimal notation IP address appears as 4 numbers separated by periods. So an example would be of an IP address of 192.168.1.1. That's what your computer recognizes. And so when you go to a website, say you go to walmart.com, their IP address might be 216.14.13. something. So it's a lot easier for us to remember the domain name than it is the IP address. It used to be you had to know those numbers. And let me get to domain name here. And the domain name, again, this is an example they give, sandiego.edu. The www part is the protocol, so that's World Wide Web. You could have one that says HTTP, which is Hypertext Transfer Protocol, or you could have HTTPS, which is Hypertext Transfer Protocol Secure. And then the San Diego, that's considered the domain name, and then the .edu is actually the top level domain. These are assigned by an institution called ICANN, which is the Internet Corporation for Assigned Names and Numbers. But these translate into IP addresses. So again, we type in sandiego.edu, the computer says, oh, that goes to 214.whatever. The web uses hypertext markup language, HTML, which is what that stands for, hypertext markup language. And that's what our browsers read. And our browsers run on top of our computers, and it just translates the data to go across to the internet. We have HTML tags, and this is part of, if you took a class to learn about HTML programming, then you'll learn about HTML tags, which are enclosed in angle brackets, like it shows here. If I wanted to bold text in my HTML document, I would start with a left angle bracket and then type in bold and then close it with a right angle bracket. So this was a very quick overview of this chapter. But this chapter is important because we're all using the internet. So if you have any questions or concerns, please let me know. And thank you for listening.